Welcome back, mathematicians. In this video, we are going to discuss intercepts. An intercept is the point, and because there could be more than one point, I'm going to put an S in parentheses to indicate that there could be more than one, although there could be only one, if any exist. So this is to indicate that there could be no intercepts at which the graph touches or crosses an axis. So I want to highlight two words that it could touch or cross the axis and still be considered an intercept. So now let's look at the two specific types of intercepts that we will encounter in the XY coordinate plane. So I've got a coordinate plane here, and my x-axis is the horizontal axis, my y-axis is the vertical axis, and x-intercepts are where my graph will touch or cross the x-axis. Now, anytime the graph touches or crosses the x-axis, it means that that point is on the graph. So I'm going to plot points on the x-axis and see if we can identify anything in common with those points. Now, I don't have any markings on my x-axis, so I don't know where they're at on the x-axis, but what I do know is that the y-coordinate of each and every one of these points is 0. Every single one of them has a y-coordinate of 0. As a result, that's how we algebraically find the x-intercept. We replace y with 0 and then solve for x, and this will give us our x-intercepts. Likewise, the y-intercept occurs when the graph touches or crosses the y-axis. So I'll plot a few points on the y-axis and see if we have anything in common with those points. Again, I don't know where exactly they're located on the y-axis, so I don't know their y value, but I do know that each and every one of these points has an x-coordinate of 0. And as a result, we can use that to algebraically find the y-intercepts. So in this case, we will replace x with 0 and solve for y, and this will algebraically give us our y-intercepts. Let's use that strategy to now find the x and y-intercepts for these two equations. So let's start with the x-intercept for the first equation. And if you recall, we are going to replace y with 0. So it'll be 0 is equal to x plus 6, and we are now going to solve for x. So let's subtract 6 to both sides. And so what we get is negative 6 is equal to x, or we could write that as x is equal to negative 6. Now, I could also rewrite this in ordered pair format, so the x-intercept is negative 6, 0. Let's now find the y-intercept. So the y-intercept, similar process, I'm going to replace x with 0. So y is equal to 0 plus 6. In this case, I just need to simplify the right side. 0 plus 6 is 6, so I get y is equal to 6. This gives me the y-intercept of 0, 6 in ordered pair format. Let's go to my second equation, and similarly, let's start with the x-intercept. Now I will replace y with 0, so it'll be 2 times x plus 7 times 0 is equal to 14. 7 times 0 is 0, so I have 2x plus 0 is equal to 14, which I could just rewrite as 2x, since 2x plus 0 is just 2x. Now I'd like to divide both sides by 2. To give me x is equal to 7. So my x-intercept is an ordered pair of 7, 0. Let's now find my y-intercept. And my y-intercept will be found by replacing x with 0. So it'll be 2 times 0 plus 7y is equal to 14. 2 times 0 is just 0, so I have 0 plus 7y is equal to 14. And so then 0 plus 7y is 7y. I now need to solve for y by dividing by 7 to both sides to give me y is equal to 2. So my ordered pair for this intercept is going to be 0, 2. So the intercepts for this equation are an x-intercept of 7, 0, and a y-intercept of 0, 2. All right, guys, good luck.